Hello everyone. Let's go ahead and solve this problem that has 4 resistors. 2 of the resistors are connected in parallel, and the equivalence of those 2 resistors connected in parallel is connected in series with another 2 resistors. So basically what we have here, we have this resistor that's called R1, and then we have R2, which is equal to 3 ohms. We have R3, which is equal to 5 ohms, and then we have R4, which is equal to 6 ohms. So R1 are equivalent of 1 and of 2 and 3 are equivalent of 2 and 3, so I write it as just R2, 3, and R4, those are connected in series, while R2 and R3 are connected in parallel, R2 and R3. So this should be your first observation. This is the first thing you need to observe when you look at this circuit. The second thing you should know is how the current and the voltage are distributed through series connection and parallel connection. Let me remind you here that in series connections, current is the same while voltage is distributed. So what does that mean here? In our case, we have 3 resistors in series. It's resistor number 1, the 8 ohm resistor, resistor number 4, the 6 ohm resistor, and the equivalence of those 2 resistors. When we find the equivalence of them, those 3 resistors, R1, R4, and the equivalence of R2 and 3 and R3 are connected in series, meaning they have the same current going through them. So the current from B to C will be the same as the current going from D to I. Okay, notice I said D to I, not G to H or E to F. Those are branches. But the current going through B and C, from B to C, will be the same as the current going from D to I, the same as the current going from J to K. Okay, so the current I from B to C is equal to the current from D to I, equal to the current going from K to J. The only time the current will split is when you have junction. Like at this junction here, the current will split and then it will merge again at this junction. So the current going through D will be the same as the current go through I here, which will be the same as the current going through J and K, between J and K, and in turn equal to the current that came from B to C. So the current will be the same, while the voltage will be distributed. What do we mean by the voltage will be distributed? We have total voltage of 12 volts. V total here in this circuit is 12 volts, and this voltage will be distributed among 3 resistors. R1, the equivalence of R2 and R3. Again, I'm not saying R2 and R3, I'm saying the equivalence of R2 and R3, and R4. So the voltage will be distributed among those. Now, which one will take the biggest voltage? We know that the voltage V is equal R times I. And since I here is the same, all of them will have the same I, which will be I total, whatever I total is, then the voltage will depend on the resistance. So the one that has biggest resistance will get the biggest voltage, and the one that has the smallest resistance will get the smaller voltage. Okay, so which one among those resistors will get the biggest voltage? Is it the 8 ohm? Is it the equivalence of R2 and R3, or is it R4? And the answer is, since R1 has the biggest resistance, therefore it will have the biggest voltage drop. So the biggest voltage drop will be between point B and point C. That will be the biggest voltage drop. Followed by, we know that when we have resistors connected in parallel, the equivalence of those 2 resistors will be smaller than any individual resistor. So the equivalence of R2 and R3 will be smaller than 3 ohms. Okay, and later actually when you do the calculation, you'll find that the total resistance is around 1.88 ohm. So this total resistance will be around 1.88 ohms. and therefore it will have the smallest voltage. The smallest voltage drop will be between D and I, and then the second voltage drop will be between I and K. So the one that will have the biggest voltage is R1, followed by R4, and finally the equivalence of R2 and R3. And of course the voltage across R2 and R3 should be equal since they are connected in parallel. So now we answer a very important question, how the voltage will be distributed and how the current will be distributed. Here in the case of series connection, we have series connection, the current is the same, so the current going through R1 will be the same as the current going through R4, will be the same as the current that goes through the equivalence of R2 and R3. Again, I'm not saying R2 individually or R3 individually, it's the equivalence of R2 and R3. Now how about the parallel connection? In parallel connection, and we only have two resistors in parallel here, the voltage is the same across the resistors that are connected in parallel, while the current will split. Okay, now what do we mean by the voltage is the same? This means that the voltage across E and F, which is across the 3 ohm R2, will be the same as the voltage drop across R3, across the 5 ohm resistor between G and H. So the voltage drop from G to H is equal to the voltage drop between E and F. Okay, so those two resistors will share the same voltage. So the voltage drop here across R2 is equal to the voltage drop across R3, meaning V. This means that the voltage drop between point E and F is equal to the voltage drop between point G and H. Okay. And of course this voltage will not be equal to the 12 volts because the 12 volts will be distributed among 3 resistors in series, among the 8 ohm, among the equivalence of R2 and R3, and among the 6 ohm here. So that's the voltage, that's the current, the voltage. The current will split. Now the question is, which one will get bigger current? Now the current that goes through R1 here, through the 8 ohm resistor from B to C, will reach this junction and it will split into 2 currents. Okay, it will split into 2 currents. Let's call it I2 and I3. I2 will go through R2, which is the 3 ohm, and then meet at this junction with the current that goes through R3 and form I total again. So I total will go through R1, pass through it, reach this junction, split into I2 and I3, then meet again as I total. Okay, so apparently here the current that goes through either one of those resistors is smaller than the current that goes through R1 and R4. Why? Because the current that goes through R1 and R4 is I total, and I total will split on this junction. Now the question is, how about R2 and R3? Which one will get the biggest current? Since the equation of the current is I equal V over R, therefore the one with the biggest resistance will get the smallest current. Okay, so which one has smaller resistor? Is it R2 or R3? Of course it's R2, 3 ohms. So R2 will get bigger current than R3 because it has smaller resistor. So hopefully now we can answer the questions number 1 and number 2. So let's go back to the questions here. So here in question number 1, to ask you the current at location A, which is this one here, and this will be I total. Remember, I total is coming out of the battery, going through A, B, C, D, then it will split at the junction between the 3 ohm and the 5 ohm resistor, then it will meet again and go through the 6 ohm. This will be I total. So in part A, the current at location A is greater than, equal to, or less than the current at location B. Of course, since there are no junctions, then it's equal to, and that's because there are no junctions between B and C. Okay, question number B, or part B of question number 1. The current at location B is greater than, equal to, or less than the current at location E. Now B is here and E is here. And as we learned here, the total current is going here to A, then to B. There are no junctions, so no splitting, through C, through D. Then as soon as the current hit the junction, it will split. Okay, so as we expect, the current through B will be bigger than the current through E that took only portion of the current. So it will be greater than. Okay, let's look at question C. The current at location G, and that's here, location G, is greater than, equal to, or less than the current at location F, which is here. Now, of course, the current that goes through G is the same as the current go through the 5 ohm resistor, and the current that goes through F is the same as the current that go through the 3 ohm. As we mentioned, the one that will determine which one will get the biggest current is the resistance, and since I is V over R, therefore the one with the less resistance will get the bigger current. And here the one that with less resistance is the 3 ohm. So the current through G, which go through the 5 ohm, will be less than the current that go through F, which is the current through the 3 ohm resistor. Because the less the current, the bigger, the less the resistance, the bigger the current. Okay, so that's one common mistake here. The current that go through G will be less than the current go through F, because the resistance here in this branch is bigger, 5 ohm, so it will get less current. Now let's look at question D. The current at location E, is it greater than, or equal to, or less than the one at G? So this is the same question, but in the way around here. Since again the current here through E will be the current through 3 ohm resistor, so it will be greater than the current that go through G, because 3 ohm resistor is smaller than the 5 ohm, so it will take greater current. So this will be greater than the current through G. Then question number E. The current at location B, which is this one here, which take total current, will be greater than, equal to, or less than the current through F. Now again, F here, the current will split, so we expect that current that goes through B is actually greater than. Okay, question F, and we have two F here. Let's call this one G actually. Question number F. The current at location A, which is here, and again it will be total current going through it. What's this relation with the current at location L? This one here. And again, since there are no branches, there are no junctions, then the current that goes through A will be the same as the current that goes through I, J, K, and L. So it's equal to. And then finally, the current that goes through H, which is here, this is H. How it's related to the current that goes through I? And of course, I will be bigger current because here the current split at the junction, then again it will merge coming out of this junction to I. So it will be less than. Okay, so hopefully that answered question number 1. Now let's look at question number 2, which actually have most of the mistakes. Question number 2 about the voltage. Let's look at part A here. Okay, the voltage drop between B and C. How it's related to the voltage drop across J and K. Okay, B and C, J and K. Now as we mentioned, the voltage is equal Ri, B equal Ri. And since the current that go through B to C is the same as the current that go through JK, so current is constant, the determining factor will be the resistance. The variable is the resistance. So the bigger the resistance, the bigger the voltage. Voltage and resistance are directly proportional, unlike the current and resistance here that are inversely proportional. So here the constant is the current, so the two variables are resistance and voltage. The bigger the resistance, the bigger the voltage. So since the resistance between B and C is bigger than the resistance between K and J, therefore the voltage drop will be greater than. Okay. So that's question A. Question B. The electric potential, the voltage difference between point B and K, which is from here to there. And that will be actually the voltage difference across the whole circuit. If we connect the voltmeter between B and K, this will measure the voltage across the power supply, the 12 volts. So the voltage here is actually 12 volts. So is it greater than, equal to, or less than the electric potential between D and I? Now D and I is only, now the voltage drop across D and I will depend on the resistance that represent the equivalence between the 3 ohm and the 5 ohms. So it's much less than the voltage drop across the whole circuit. So definitely the answer is greater than. Okay, let's look at question C. The electric potential difference, the voltage drop between points E and F, is how it's related to the voltage drop between G and H. So E and F is the voltage drop across this 3 ohm resistor if you connect a voltmeter. How would the voltage drop between E and F be compared to the voltage drop across G and H? Now remember, in the case of parallel connection, and here the 3 ohm is connected to the 5 ohms through a parallel connection, so the voltage drop will be exactly, it will be the same. So the voltage drop will be equal to. So again, in the case of parallel connection, the voltage is constant, and so the voltage drop from D to I is the same as the voltage drop from E to F is the same as the voltage drop from G to H. So it's equal to. And that's a common mistake here. Okay, if you look at the question D, the voltage drop between E and F, how is it compared to the voltage drop from D to I, which will be from this point to this point. Again, if you connect a voltmeter here, and the answer is exactly the same. Again, if you look at the potential here, the potential between D and F is the same. There are no resistors between D and F. The only time you have voltage drop is when you have resistors. So between D and E, there are no resistors, so the potential is the same. And the same thing between point D and G. There are no resistors, so the potential is the same. And the same thing here, between point F and I, there are no resistors, so the potential is the same. And between H and I, there are no resistors, so the potential is the same. So the voltage drop, which is the potential difference between D and I, will be exactly as the potential difference between E and F, exactly the same as the potential difference between G and H. So it will be equal to. Now question E, the electric potential difference, the voltage drop between J and K, which is between the 6 ohm resistor here, if we place a voltmeter here, how will it be related to the voltage drop between D and I, between this point and this point? Now recall that 6 ohm resistor here is connected in series with the equivalence of the 3 ohm and the 5 ohms. Okay. So what will determine the voltage drop is the equation V equal R times I. And here we have series connection between the 6 ohm and the combination between the 3 and the 5. So the voltage will split among them. And what will determine the voltage portion of each one is the resistance. The bigger the resistance, the bigger the voltage. Now since 5 ohm and 3 ohm are connected in parallel, their equivalence resistance will be less than any individual resistor. When we calculate it later, we'll see that it's around 1.87 or 1.88 ohms. So it's much less than the 6 ohm. Therefore, the voltage drop across the bigger resistor will be bigger. So it will be greater than. Now the last question here, the electric potential difference between point L and A, which will be the voltage difference between the power supply here, L and A, is it greater than, equal to, or less than the voltage drop across B and K, meaning between this point and this point. Now again, if you look at L and K, they are the same point basically. There is no resistance between them, so they are the same point. And also A and B are the same point. There are no resistors between them. So basically the potential at A is the same as the potential at B, the potential at L is the same as the potential at K, therefore the potential difference between A and L is the same as the potential difference between B and K. So it's equal to, and this is a common mistake here. Remember, what will determine whether there is difference in the potential difference is the existence of resistors. If there are no resistors, then there is no voltage drop, and therefore the voltage is the same. Okay, so that was the answer to question 1 and 2. Now let's see question number 3, which has actually, there are many mistakes in it. Okay, in question number 3, we are asked to find the electric current, the total resistance, the total current, and the current and the voltage, the current through each resistor and the voltage drop across each resistor. So let's start with the total. Now in order to find the total current, of course V total, we are given V total is basically 12 volts. We have that. We know the resistance of each resistor. Now to find R total and I total, we know I total, the total current in the circuit, will be equal to the total voltage over the total resistance, which will be the resistance that is equivalent to those 4 resistors. And again, let's call the 8 ohm here R1, the 3 ohms we'll call it R2, the 5 ohms we'll call it R3, and then the 6 ohms we'll call it R4. So to find the total current, we need to find the total resistance, and in order to find the total resistance, we have to find the sum of the resistors. Now let's analyze the circuit in order to find the total resistance. As we mentioned, we have the 8 ohm connected in series to the 6 ohms here. R1 and R4 are connected in series, and both of them are connected in series to the equivalence of R2 and R3. So we can actually change the circuit here to, this is R1 and then R equivalence and then R4. So this will be R1. This will be R equivalence of 2 and 3, and then this will be R4. And R equivalent of 2 and 3, we can find it using the equation. R equivalence of any two resistors connected in series is equal to 1 over R2 plus 1 over R3. So basically it's 1 over 3 ohms plus 1 over the 5 ohms, and if you carry out the calculation, this will give you 1.875. So this represents the equivalence resistance of 2 and 3. So we'll call it R2 and 3. So now we can find the total resistance by adding those 3 resistors that are connected in series with each other. R1, that is equal to 8 ohms. The equivalence of 2 and 3, which is equal to 1.875 or 1.88 ohms, and R4, which is equal to 6 ohms. If we add them, our total will be 8 ohms plus 1.875 ohm plus the 6 ohm, and this will give you total of 15.875, or if you round it off, just 15.88 ohms. So that's the total resistance. Now we have the total resistance in the circuit. So now we can find I total. I total will be V total, which is 12 volts, divided by R total, which is 15.88 ohms, and this will yield the total current, which is 0.76 amps or ampere. or A for short, we can just write A amps. So now we got the total current. Now we know that the total current will go through A, B, then through the 8 ohm, so it will be the current that go through R1, and then it will be the current that go through D, and then it will split on the junction here between R2 and R3, and then merge back into R4. So by finding I total, we were able to find also the current that go through the 8 ohm resistor R1, and we were able to find the current that go through R4, the 6 ohm resistor, which will be equal to I total, which is 0.76 amps. So that's the current that go through the 8 ohm resistor and the 6 ohms resistor. Okay, so now how about the voltage? We were able here to find the current I1 equal to I4 equal to I total, which is equal to 0.76 amps. Now how about the current through the 3 ohm and the 5 ohm resistor? Now at that point the current will split, as we learned, between the two branches, and the amount of the current that will go through the 3 ohm and the 5 ohm resistors will depend on the voltage across the 3 ohm and the 5 ohm resistor. So in order to find the current, we have to find the voltage first. The current will split based upon the resistance, so the one with the less resistance will take bigger current. But in order to find the current, we have to find the voltage. So let's split the page here and have part for the voltage. Now with regard to the voltage, we know the voltage will split among the 3 resistors connected in series. So there will be voltage drop across the 8 ohm resistor, then voltage drop across the equivalence of resistance 2 and 3, and then the voltage drop across the 6 ohm resistor. And the sum of those voltages will be equal to 12 volts. Okay, will be equal to 12. Now how much voltage will drop across the 8 ohm resistor? How much the 8 ohm resistor will get voltage? V1, which is the voltage across the 8 ohm resistors, will be equal to the current that goes through the R1 times the resistance of R1. Now I1, we already found it is 0.76 amps, so this is equal to 0.76 amps times the resistance, which is 8 ohms. So if you multiply the current here, this will yield 6.08 volts. So this is the voltage drop across the 8 ohm resistor. Then let's find the voltage drop across the resistor number 4, the 6 ohm resistor. It will be I4, which is also equal to I total, we already found to be 0.76 amps, times R4, which is 6 ohms. So when you multiply 0.76 amps by 6 ohms, this will yield 4.56 volts. And you expect here the resistor to be, the voltage drop to be less than V1. V4 should be less than V1. Why? Because R1 or R4 is less than R1. R4 is 6 ohms, R1 is 8 ohms, so the voltage drop across the 6 ohms should be less than the voltage drop across the 8 ohms. Okay, so we find the voltage here between B and C, and the voltage between K and I, K and J, the voltage drop across resistor 1 and resistor 4. Now, in order to find the voltage drop across R2 and R3, we need to find the voltage drop across the equivalence resistance. So V across 2 and 3 will be simply the electric current that will go through our equivalence, which is the total current. Because remember, this is the circuit here. When we combine the two resistors, we have R1, then the equivalence of the two resistors, then R4 here. So this is R1, this is R equivalence of 2 and 3, and here we have R4. So the current that goes through R1 is the same as the current go through the equivalence of 2 and 3, equal to the current that go through R4, which is equal to I total. So R total times R equivalence of 2 and 3. So this will be equal to 0.76 amps times the equivalence of 2 and 3, which we found it to be 1.875 ohm. And when you do the multiplication, the voltage drop here will come out to be 1.43 volt. And we expect it to be small because the total resistance here, or the equivalence resistance of 2 and 3, is smaller than R1 and R4. It's only 1.875 ohms, in contrast to 6 ohms for R4 and 8 ohms for R1. So always ask yourself if your answer makes sense. And this will be the voltage drop across V2 and V3 since they are connected in parallel. So V2 is equal to V3 is equal to the equivalence of 2 and 3, which is 1.43 volts. Okay. So now we have the voltages across all the resistors, the voltage across R1, the voltage drop across R4, and then the voltage drop across R2 and R3. So now we can go ahead and solve for the current that go through R2 and R3. So I2 would be equal to the voltage across R2 divided by the resistance of R2. And the voltage is 1.43 volts divided by the resistance of R2, which is 3 ohms. And this will yield 0.48 amps. The same thing, we can find the current that go through R3. Let's call it I3. It would be V3 over R3. V3 is 1.43 volts divided by R3, which is 5 ohms. And this will yield 0.29 amps. So now we have the current that goes through R3 and the current that goes through R2, in addition to the current that goes through R1 and R4, that's 0.76 amps. As you expect here, the sum of the current that goes through R2 and R3 is equal to the total current, which is the current that go also through R1 and R4. So 0.43 plus 0.29 is almost equal to 0.76, with of course some differences due to the rounding off. I'm sorry, this by the way, this is 0.48. Yeah, this is 0.48. So yeah, 0.48 plus 0.29 is very much close to the I total here.